Hi, folks. Quickly wanted to cover this paper which came out just a week ago. This is a great empirical study of the agents that are actually out in production right now. So the authors over here went out and did a survey of about 300 practitioners in the field, as well as in-depth interviews with a subset of them to figure out a very comprehensive picture of what kind of agents are being deployed and what the challenges with them are, and so on. And I have to agree with pretty much everything they found. It matches a lot of my experience anecdotally talking to people and customers and so on. But it's great to have some good numbers around this. So let's jump right into it. To start with, why build agents at all? The answers are not surprising at all. Of course, you want to increase productivity. You want to reduce the amount of time people spend on very routine cognitive tasks. So that's pretty expected. And it's great to see that the domains in which all these agents are deployed, finance, banking, technology, corporate services, it's a wide variety of domains. So it's not just tech, it's not just software engineering and tech. So that gives additional credence to the study in that it's very broad. And one more quick point, the time period that the survey covers is from late July 2025 to late October 2025. So these numbers are very current. Okay, now let's get into the properties of these agents. What kind of agents are people building? And the vast majority of agents are for internal employees and external customers, but the point being that they are for human users. So only a tiny fraction of agents are talking to either other agents or the software. So the agents are still very much for human consumption. The other notable thing is, because this was a topic of a lot of debate in the community, is what are the latency requirements for these agents? And it looks like people are satisfied with the agent operating on the order of minutes. So we're still not seeing any hard requirements, at least by and large, for agents that have latency requirements of seconds or sub-seconds. The thing that people want most from these agents is high quality output that saves them time, and they're okay with waiting for that. Another couple of points about the infra and stack used by these agents. In terms of what kinds of models they use, the vast majority use closed source models. So things like Claude and Gemini and ChatGPT. And only a small number use open source models like Llama and so on. And those are because they have very niche requirements around privacy or production deployment and so on. But I think the discourse is dominated by a lot of these use cases that say they want to use open source. But as you can see in production, the majority of people are happy with just using good closed source models. The other thing that gets a lot of coverage is whether you want to do any post training, any supervised fine tuning on your agents. And again, the vast majority are just using models along with prompts on top, and there's only a small fraction, 6 out of 20, that are doing their own SFT. And the thing to note there is that SFT is much more work, and you should only do it when the gains from SFT are justified by that amount of development overhead. So you have to be very mindful of when you choose to do SFT. And even when you are doing SFT, it is almost always in combination with vanilla LLM. So it's extremely rare to see an app or an agent that is only using SFT models. How do people write the prompts for their agents? By far, the most popular method is manually writing these prompts along with some AI refinement. So you use an LLM to ask it to refine your prompt. And then a lot of people just fully manually write their prompts. One somewhat surprising finding is that Only a small minority use prompt optimizers like DSPy. These are automatic prompt optimizers where you give it a bunch of input-output examples and the framework goes and finds an optimal prompt for you. And in theory, you would think that this is great, but people want to have full control and transparency over their prompts. And also, often it's hard to find a good set of input-output examples. So even though in theory you'd want to always use a prompt optimizer, in practice, what you see is people are just rolling their own prompts and sometimes using AI to refine those prompts. Okay, now we come to the big question of agent autonomy. This is, I think, a huge topic of debate in the community, this whole question of workflows versus agents. And the picture that this survey paints is also very aligned with what I've seen anecdotally, which is that production agents are heavily leaning towards structured workflows with, as they say, bounded autonomy. So most customers don't want fully autonomous agents that are coming up with their own plans. They want the agent to follow a predefined set of steps. And as I say over here, the vast majority of agents complete in just 1 to 4 steps, and then a few more complete in 10 steps. So something like 3/4 of all agents only have less than 10 steps. Again, most customers do not want full open-ended autonomy. They found that 80% of our case studies utilize a structured control flow. So workflows seem to be dominating deployed agent use cases as opposed to agents like, say, Claude Code that are autonomous in the sense of coming up with their own plans. I have a previous video about how those kinds of coding agents are a bit of an outlier. And this seems to confirm that intuition. If workflows versus agents is one huge debate in the community, the other one is framework or no framework. And here the survey finds somewhat contradictory signals. As I say over here, among the deployed agents, 2/3 used some kind of framework, and which framework? LangChain seems to have the most market share with 25%, followed by Crew at 10%, and then the others like Llama Index are much smaller. But here's the contradictory part. If you look at the detailed case studies that they interviewed, the builders of whom they interviewed, only 3 out of 20 used a framework, and the rest just rolled their own code. They built it in-house with their own React loops. And they did it because when deploying to production, they wanted to have control over their full stack, and they didn't want the extra layers and abstraction that come with a very heavyweight library like LangChain or LangGraph. So as I say, they wanted flexibility and control and simplicity. And couple that with the fact that writing a core agent loop or rolling your own React agent loop is not that hard if you can just make direct API calls to the underlying LLM. And then we come to another huge question, which is how are agents evaluated? And here again, you find that the picture is very, very messy. So the good news is that about 40% compared their agents against some predefined baseline, where the predefined baseline could be an older non-agentic software system or human execution. However, what that means is 60% do not perform any baseline comparisons at all. And sometimes that's because, as they say over here, no meaningful baseline exists that you can compare with. But other times it's just because it's really hard to come up with a baseline comparison because the task that these agents are doing may not correspond 1-to-1 with some existing baseline. So constructing a baseline or a benchmark or an eval is really hard. And a minority built their own benchmarks, as they say, 5 out of 20. But the majority seem to be evaluating their agents without benchmarks, which sounds contradictory. What are they doing exactly? So they're basically depending on monitoring and user feedback. In other words, vibes. So they look at the outputs coming out of the agents and they ask human domain experts to look at and rate these outputs. As I say over here, 3/4, the majority rely on manual human in the loop evaluation using domain experts, operators, or end users. And then they use LLM as a judge, but that is in addition to these more human expert evals. So that paints a good picture of how agents are built, how they're deployed, and brings us to the question of what are the big open challenges. And the number one challenge that they identify is reliability. Now, what do we mean by reliability? It's kind of an umbrella term that covers a lot of things, but essentially it means making sure that agents work consistently and correctly. So they're giving you the outputs that you expect, and they're giving you the same output repeatedly. And so you might say that's a bit of a contradiction because people are saying reliability is an issue and yet they're deploying it. But the way they're tackling reliability is by heavily constraining the autonomy of these agents, which goes back to this point this paper was discussing earlier about workflows versus agents, where workflows are highly constrained. They follow a predefined set of steps, and you're giving them guardrails. And you do things like running them in read-only mode so they can't actually write back to production databases. So this was a really illuminating paper in terms of what is realistically deployed out there with AI agents and how there is a fair amount of real world deployment, but it is much simpler and much cruder, so to say, than a lot of the discussions that are happening in the larger AI agent community. And by that, I mean things like they're using workflows rather than open-ended agents that make their own plans. They're rolling their own agent loops rather than using huge libraries or frameworks like LangChain. And they're heavily depending on human expert evals as opposed to well-structured benchmarks. So there is a lot of deployment, but it's heavily leaning towards simple and constrained deployments. So I hope you enjoyed that. If you like content like this, consider subscribing, like the video, and I'll see you next time. Thank you.